From the beautiful South Studios of Way Happy, this is Mr. Meyer and 2.3 polynomial functions. And so what are we going to talk about? We're going to try to talk about how you can recognize what this graph is without having to do a bunch of work, right? Or at least too much work. So when we talk about polynomials, you know what they look like. You got to talk about their end behaviors, the first thing we're going to say. And so first thing you want to know is if you have an even power, I want you to remember that your even powers will always go up on the right, and if it has a positive leading coefficient, and if it's an even power, it'll always copy it on the left, right? If it has an odd power, well, but a positive coefficient, then it will go up on the right because of the positive coefficient, but an odd power will make it do the opposite on the left. And if you have a negative leading coefficient, then the right side will go down. So that would be actually true, I should tell you, on both of these. So a negative coefficient will make the right side go down. But if it has an even power, well, then we know that the left side will also go down. And if it has an odd power, we know the left side will go up. And so how do you write that end behavior? Well, there it is underneath. The limit, let's do that first box. The limit as f goes to a negative infinity. So as you go left, the graph goes to infinity. As you go right, the graph goes to infinity. Now the second box over here on the right side, as you go left, it goes to negative infinity. As you go right, it goes to infinity. Here we've done the bottom ones. As you go left, it goes to negative infinity. As you go right, it goes to negative infinity. And this last guy, as you go left, it goes to infinity. And as you go right, it goes to negative infinity. And that is your end behavior. So how do you describe end behavior if I just give you an equation? Well, plain and simple. First thing I do is I look at this, right? First, make sure it's written in order, which it is, for goodness sake. And this will tell me what the right side does. If it's positive, it goes up. If it's negative, it goes down. So right side's going up. Now this exponent will tell me what the left side does. And if it's even, it copies. And if it's odd, it does the opposite. So the left side copies. So the left side also goes up. So how do I write that? The limit as x goes to infinity, that says right side, then the function goes up, and then the limit as the x goes to negative infinity, the left side, the function goes up because they both went up. So again, remember, we could condense that to just say the limit as x goes to plus or minus infinity, the function goes to infinity. That's just one way to write it in one way instead of having to do two ways. All right, what about this next guy? Again, look at the leading coefficient. That tells me that the right side is going down. Look at the exponent. That means the left side does the opposite. So the left side goes up. And so if somebody asked me what this does, I would say the limit, and notice they're different, so I got to make two sentences. As x goes to, let's say, the left side, negative infinity, the function will go up. And the limit as x goes to infinity, the right side, the function will go down. And that is end behavior. All right, let's talk about zeros. Zeros are when you have an equation that equals zero. They're also known as x-intercepts of a graph. We factor and we find those answers. So here we go. If I want to do this, I'm going to say, all right, y equals, well, let's change it to zero because I want to know the zeros. X cubed minus 16x. Well, I'll factor out an x and be left with x squared minus 16. Hey, wait a minute, that's the difference of squares. So that's x plus 4, x minus 4. And lo and behold, I have found all the zeros. The zeros are x equals 0 for this guy, x equals negative 4 for this guy, and x equals 4 for this guy. And for those of us who want to see this graphically, I could use a graphing calculator. I could use Desmos, and we should be able to see what we're getting. So as I pull up the graphing calculator, you will see that, let me see first what this equation was. I already forgot. X, so y equals x to the third minus 16x. And now if I go ahead and graph that, we should notice 0, -4, and 4. So I'm going to zoom 6 to get a normal window. And we see, look at that, -4 is an x-intercept, 0 is an x-intercept, and 4 is an x-intercept. And so I've just supported it graphically. Now, what about multiplicity of zeros? And that I want to get through too. And it is, I want you to tell me the zeros and the multiplicity. It just means that a zero could be an answer more than once. So if you look at this one, if you go to solve this first one, you might notice that you get one answer as x is 0, and then you get x is 3 and x is 3, or you get 3 2 times. So that's called a multiplicity of 2. So 0 is an answer, and 3 is an answer with a multiplicity of 2. Then you have this guy. You have x is -1. You have x is 2 with a multiplicity of 2. And you have x is 4 with a multiplicity of 3. Now notice what I asked you here was to graph this. So let's graph this first one. So if I go y equals x, clear this out actually, x minus 3 squared, and then I hit graph. Notice the graph we have at 0, and notice at 3 we kind of bounced off. That's because the multiplicity was 2. When you have a multiplicity that's even, the graph will bounce off the x-axis. But let's just make sure with this next one. So y equals, I'm going to clear this out, x plus 1, and then x minus 2 squared. So x minus 2 squared, and then x minus 4 cubed. And if I hit graph, notice we see it go through -1, we see it go 2, and we see it go through 4. But notice what happens. At -1, it went through the x-intercept. At 2, it bounced off. And at 3, or at 4, it went through again, but kind of a little zigzaggy before it went through. Again, because of the multiplicity. Odd multiplicities make you slice through. Even multiplicities make you bounce off. And that's what we want to say here. So a 0 with an even multiplicity will bounce off the x-axis, and a odd multiplicity will slice through the x-axis. So, in short, when you solve these things, you go ahead and you solve them, and if they have different multiplicities, that's when you know what the graph is doing. If it's even multiplicity, it's bouncing off the x-axis. If it's odd, it's going through. And if the more odd it is or the more even it is, just the more rounded the bounce becomes, or more rounded the slice through becomes. It doesn't come a clean slice. It just has this weird, funky change of direction in it, but it still goes through with odd multiplicities. All right, let me ask you a question, and I will be right back. All right, excellent work. Now let's put it all together. So I'm going to try to slow down here and make sure we get everything. So as you see this first problem, we're going to do everything. We're going to state the degree, the leading, we're going to do the zeros. I mean, we're going to do everything. So this is a problem that I would give you to sketch on a piece of paper, and you would have to then tell me all the crucial parts. So you might notice we know the degree is 4, and the leading coefficient is 1 then, because whatever's in front. Now, what does that tell me? Well, a degree, first of all, a positive leading coefficient tells me that the right side of the graph goes up, so end behavior, and the even exponent tells me that the left side copies. So a nice thing I know about this graph is that I know over here on the right it's going up, and over here on the left it's going up. So I have a little idea of what the graph looks like. Well, then the next thing that might be able to be nice to do is that you're going to go ahead and solve this. So 0 equals x to the 4th minus 25x cubed. First thing I'll do is factor out an x cubed and be left with x minus 25. And the good news is I'm done there with factoring. Notice I know x is 0, and that has a multiplicity of 3, meaning it slices through. And I know x is 25, which has a multiplicity of 1, and that means it slices through also. So At 0, it will slice through. And at way over here at 25, it will also slice through. It'll actually go right on through. Now, it's always fun too to think about what the y-intercept would be. So the y-intercept is when x is a 0, and you can notice that for this problem it's not very exciting, because if x was a 0 and we plug it back in, it's the 0.00, which we already knew because x was 0. So we know the left side goes up, we know the right side goes up, we know the graph kind of goes through at the origin. And so here's my sketch. If it goes up on this side, it's going to come down, it's going to do a little slice through like that. Then it's got to turn around at some point so it can go through 25 and get out of here. And so that's what I would expect my graph to look like. Now, do I know how far down to go? No. Is it exact? No. I mean, this point right here, I really don't know how far down I am. So that's just a guess. But that's what the graph would have to look like. And heck, I could even take my calculator, and it's going to be a horrible window because it's not going to go to 25. But let's see what I get. X to the 4th minus 25x cubed. And if I go ahead and zoom 6 this, probably not going to see a whole lot except for maybe going through there. Oh, that's kind of cool. But if I change my window, maybe I can change my x's to go to 30 and my tick marks every 15 or so. And maybe I'll make our y's go down to negative 50. I don't know how low it goes, but let's see. There is my graph, and oh, it went way down, and it should it came back up. Not a whole lot good to see there. It goes apparently a lot farther down than whatever I had put in, 50. So you could mess around with this window a little more if you wanted. I'm going to try negative 100, and then if that doesn't look too pretty, I'm out of here. And I will graph that. So yeah, it's done. It's out. It's through. So that's really, really deep. Kind of a bummer. All right, let's see what we got next. Look at this guy. Now this one's a little tricky because it's got, it needs to be foiled out so I could do end behavior, or you can just kind of think about the end behavior. It's going to have a negative 3, and it's going to have an x and an x squared. So it's going to have a negative 3x cubed. So that right there tells me the right side's down and the left side is up. So I already know that about the graph just from knowing end behavior or looking at the leading coefficient or whatever you want to call it. So we know the right side goes down. We know the left side goes up. Now let's go through and find all those zeros. So where are the zeros? Well, let's see. There's one at x equals 2, and there's one at x equals negative 7, and that one has a multiplicity of 2, meaning it bounces off. So if we have an intercept at 2, and we're going to go through that one, and we have one at negative 7, 1, 2, 3, 4, 5, 6, 7, we know that one's going to bounce off because it has an even multiplicity. Then the graph must go something like this. It's going to come down because we said it was up there. It's going to bounce off. Now it's got to turn around and come back through, and it's got to go through that and shoom, out of here. So it's going down on the right, up on the left. It's bouncing off at negative 7, and it's going through it too. And I probably could have found the y-intercept to make people happy, and I didn't think of it before I graphed it, but the y-intercept was when x is 0. So that would be the point, let's see, negative 2, and what is that, 49. So negative 6 times 49. Oh my gosh, I don't even want to figure out what that is. I'm sorry, positive 6 times 49. So 6 times 49, really big number. It's way up there in that y. This y-intercept is way up high. So just a little heads up on what that graph would look like. All right, other things to notice. Oh, like I've been saying, the y-intercept, right? Find the y-intercept. On this problem, the y-intercept is not 5, right? You have to plug a 0 in, so what do you get? You get 2, and then you get 0 minus 1 cubed plus 5. What is that? 2 times a negative 1 plus a 5, so negative 2 plus a 5. Oh, the y-intercept would be 3. So you can always use that to plot on your graphing calculator. Another thing to think about is, why would that problem right there, x to the 9th minus x plus 50, have at least one real 0? Can you think of any reason why that is? And the reason being is this. If it's got an odd power, we know the sides do opposite things, right? One side has to go up and one side goes down. In fact, this right side would go up, so the graph goes up over here, but the left side has to go down. And how the heck is the graph supposed to get from one side to the other without ever crossing the x-axis? It couldn't, right? That's impossible. So it at least has to cross once. Now that 9 tells me it has a lot of dips and turns, so it could be turning all over the place, but it has to cross once. Could cross through twice, 3 times, 4 times, all depends on multiplicity. But it at least has to cross through one time. And here's probably the last thing I'll do. Find the cubic function in standard form that has these zeros. This is like the opposite of bottoms up. If you know 3 is a 0, then you know that x minus 3 is a factor. If you know negative a fourth is a 0, then you know x plus 1/4 is a factor. And if you know 6 is a 0, then you know x minus 6 is a factor. And now you just FOIL that out. We got to clean it up a little bit. You know, x minus 3, 4x plus 1, and x minus 6. This is how I would make your problems on the test that I wanted those zeros, in fact, to be. So now I'm going to go ahead and just FOIL this out and make it all pretty. So I don't know, let's FOIL first here. We get 4x squared, and then we have plus x, but minus 12x, so minus 11x minus 3 when I FOILed the first two. And now it's going to get a little grosser, but I'm going to distribute the x through, and I'm going to have 4x cubed minus 11x squared minus 3x. Now I can distribute the negative 6 through, and I get, what is that, negative 24x squareds, and I get 66x, and I get 18. And so my final answer for this would be 4x cubed minus 35x squared plus 63x plus 18. And what do I mean by check with a calculator? Well, exactly that, right? You would take this and you would hit y equals, and you would type in 4x to the third minus 35x squared plus 63x plus 18. And if I zoom 6 that so I get a normal window, I should see intercepts at negative 1/4, positive 3, and positive 6, which I do, and I feel super good. I at least know that that's a great equation. All right, that's it. We'll have to talk about this other stuff in class. You guys have a great day, and I'll see you tomorrow. Stay happy.